This is the first class, right? What chapter or what topic you are going to discuss? Any idea? We start with numbers. So I know the chapter that I think completed. Right. We had sessions for workshops for this. Okay. This is start with the introduction. Okay. So I want to pass you this. So we have tried to take down the work. So we take the first syllabus. How many of you know this syllabus properly? Using exam and witness, how many of you know this? We have this. And I'm concerned here. One is how well you know your syllabus. Try to understand why this syllabus is being used. If you get the answer right, any subject is easy. Math, science. So do you know what we are doing? So most of the things what we have is studying for the same of tomorrow. Start studying for things. Right? So that is not how this class is going to be. That is not what we are trying to work on. So when you think of foundation, things already have your students. So again, if you open the next book, it's the same syllabus. Then how different is it going to be? What is your expectation? Is it explained more in detail? Is that what you see? Why it is not this foundation? You need to understand the concept. You need to work on it. Yes. That's right. So as a name scientific foundation, is something that is concept that really what is more important. Foundation is something other things to stand on top of. Similarly, your education confidence of things. Online your education subject is not what we are doing. Right? So when you come to school, you learn some subjects, especially math and science. They have a lot of texts associated with computers. We have texts with we have a science subjects. Are you agreeing to study for the sake of studying? For example, you take this. For example, I'm doing something, whatever. Speaking. Okay. I'm doing all this. What context of this thing you take? We talk about motion. So when we talk about motion, simply I'm speaking. For me to speak, I need some energy. This concept again. Right? So, kind of. Basically, science is all about how to study the nature. That is science. If you study the nature of So we have the data arbitrary. Are also what assigns. So we observe certain things and take certain data from each, right? But when you take the data, right, what is more important? You take the document. Others will be able to understand. Let's say very focused. Why this pen is working in this way? You figure out something which others will know. We want that to be in by the word. What will you document it and start something? But for you to document it, you think it is possible for you to speak a language of complete science without mathematics? Think about it. At least think about it. We need mathematics. Then talk about mathematics. What is the first thing that comes to you? Look at the way this is saying. What is the first chapter we talk about? But the basic for you to relate to any other than this. Right? So that's the reason why we have number systems. Okay. But again, like how those scientists classify different things like departments, physics, chemistry, biology, chemistry. Right? In a similar way, mathematics will have classification of branches. Right? So what may be the branches? Depending on what kind of context you are trying to meet. What do I mean by context? What kind of concept or what here you are meeting? That particular chapter falls in that particular branch. For example, you go to lines and angles. So lines and angles, what will make it because the third chapter is what? There was geometry. What geometry I meant to talk about the lines and angles. Have you heard of Euclidean geometry? So you generally call it a geometry. The geometry has something which is called as Euclidean science. So we discovered the geometry part. So that's slightly complicated. Overcome that complication with the concept of coordinate geometry. They all fall under different branches. Similarly, we talk about polynomials. You know what a polynomial is? That is how does a polynomial look? Ax squared and bx plus c, or ax cubed and bx squared and cx plus d, something like this. When you not any equation, so that you call it as a polynomial. And when you talk about a polynomial, what is expected from us? You solve for the x and then you want an answer. Right? So polynomial falls under a branch called as. Similarly, you have number system. Right? Number system, what do you think? Falls under a branch called as number theory. That is when you start. So the number system that you're going to learn for your exam is not going to stop here. Because we read it well and if you see it, you have this number theory. So you think that you're not using more of it. But without your knowledge, you still use numbers. But as science students, we need to have clarity of what kind of numbers we are trying to talk about. We cannot just say the laboratory. We need to be more clear and precise. Saying that, okay, I'm clear about the number of which I'm using. That is where you have number systems when you use quantities. So if you organize those numbers in a proper order and you kind of clear that particular branch is called as number. The topic you are learning under is called as number systems. Systematic. Are you getting a clarity? Are you getting a picture of why we are studying the first stage? That is more important. Any comments on it? Page to the steps.
Connect off on the class level. Okay, sir. Try பண்ணி வைக்கணுமா சார்? ட்ரை பண்ணி சார். பள்ளியில வேலை செய்யணும். சரி நான் வரேன். Okay. So as of now, what I will do is in the table மட்டும் போட்டீங்கன்னா தண்ணி எடுத்துக்கலாம். தண்ணி
Will you be able to come there? You guys are coming, you're able to see. Please adjust your input. I'll see how it can be resolved. Just a minute. Okay. Okay. Sorry about the technical glitch. We are going to discuss some basics. We are going to discuss some basics. Then I will bring it to the context of why you are studying. So first, if I ask the question, why do we even need number system? You're able to see that? Yeah. Why do we need number system? What is your answer? That is right. So that is what I told you. Can you give me a different perspective to it? So most basic for you to have number systems is to count something. Right? You have different objects. When you want to report something, you need to count. See, when I told you about the documentation, if you have to write down 10 points, for those 10 points, you need to put a prefix as number. Only that person will be able to understand it. So basically, to count things, similarly, if you go to a shop, okay, you want to buy oil. Okay, what will you ask the shopkeeper? You will say, give me oil. Is this how you will say, or you'll be specific about something? You'll be specific, right? You'll be using a number. Yeah. So for you to have a physical quantity, for it to be measured, you need a number associated. Okay. These are all very basics. But my question is, okay, you're going to use for the solving purpose also. So you all read computer science, right? Can you tell me where do you use numbers for computers? Votes. Codes. Okay. So codes, will you sit and write numbers? You basically type in some English, right? You write printf something. You write all the code so that the software is able to understand. Software is able to understand, okay, but will the computer be able to understand your language? So we are speaking in English. So what do? Generally, it gets converted in the backend as zeros and ones. So what do you call that kind of a system? You call it as a binary system. So basically, you can say like this also. Computers also take the help of number systems, right? So when you talk about it, there are different kinds of systems I can divide it. One is called as a decimal system. I can call one as a hexadecimal system. One I can call it as octal number system, and the fourth one I will call it as binary number system. These are categories. So when somebody tells you you're dealing with a decimal number system, what comes to your mind? Decimal is not a point. Deca is how much? Deca is 10. So if you have first 10 numbers associated from 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you use any number between 0 to 9 to represent something in mathematics, you call that kind of a language as decimal number system. If you use only zeros and 1, for example, 0, 1, 1, 0, 0, 0, 1, 1, 1. So if you look at the whole, whatever you call it, you look at the whole phase of mathematics, you use only zeros and 1. So what kind of a language did you use? Use binary number systems. Similarly, you have something called as hexadecimal. What do you mean by hexadecimal? Hexa is 16. So when you talk about hexadecimal, you have 16. Very good. So for whom do we give this kind of a language? Any idea? This is also related to computers only. So talking about the computer, right? The software will be able to understand. I repeat it, the software will be able to understand only zeros and 1. But for your computer to run, you have hardware also. You know what are hardwares? Right? You have a processor. You have a motherboard, and that you will have a processor. Right? For that processor, the language which it can understand is mission level language. For that, you need to use hexadecimal number system. Hexadecimal means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, F. So it is a combination of alphabets and numbers. Is that clear? Similarly, octal means what? Octa refers to 8. 8 means from where should you start? 0 to 1 number should be less than 7 because you're including 0. 0, 1, 2, 3, 4, 5, 6, 7. Are you able to understand? So this is how number systems are useful in computers also. So apart from that, it has applications in medical industry also. Okay, all those things consolidated. We are learning a very tiny part of it. The world is so big. We are learning a tiny part of it, which is very, very simple. That is what I wanted to say. Okay. So first, I wanted to ask you what this is. Are you able to see something like this? So this is a number line. So what is a number line in the first place? Line is a one-dimensional figure which gets extended in both the directions except. Means left hand side it will extend till minus infinity, right hand side it will extend till plus infinity, positive infinity. Means it doesn't have an endpoint. That is what the definition of line tells us. But what do you mean by the prefix number to it? Number line. What is it? So you have a line. A line, number line is basically like a scale on which, on which you can plot the numbers. Okay. For example, you have a scale, right? So if I ask you to draw 12 centimeter, what will you do? You take the 0 as a reference. With 0, from there you will correctly measure 12 centimeter. You put a point there, right? Then you will join them. So then you will get a line segment. But here, if I keep those points, I call it as plotting. So when I plot something, because I'm dealing with many numbers, I'm not going to deal only with one system of numbers. I'm going to deal with many other numbers. For those numbers to be plotted on the line, I need a system. That is what is called as a number line. Sir, no problem. Next class. Okay. So that is where you use number line, correct? But my question is, on a number line, what kind of numbers can you plot? What kind of numbers can you plot? Numbers. You can, basically you can plot any real. Basically you can plot any real number. What do you mean by real number in the first place? So real numbers are classified into two types. Basically, what are they? Rational and irrational. So again, under rational numbers, you have subcategories. What are they? So you have integers, you have natural numbers, you have whole numbers, all those things. So if you follow the correct order, right? First discovery took place with respect to natural numbers. So what are natural numbers? So 1, 2. It started with 1, 2, 3, 4, 5, 6, 7, 8, 9. So then they started thinking, how will you define the next number? Okay, so what in today's world we know that the next number is 10, but for the 10 in natural number system, you don't have a 0. So natural number, the problem they face with this, one to make this problem. After that, they didn't know what. If you want to extend the theory, what are you supposed to do next? I need a zero. Okay, so they added zero to that system, and that zero is added as a prefix to all the numbers so that you get 10, 20, 30, 40. Similarly, till 90. Again, if you add two zeros, you will get 100, 200, 300, something like that. So zero became a very important number. That is why we call them as whole numbers, because you could define numbers beyond 9 also. Okay, then they started another question. Why should numbers be associated only with positive values? Why can't they have negative values? So if you take natural numbers and you give a negative value to them, then that particular set becomes set of integers. Are you able to understand this? Then integers came. So we are talking only about the numbers between 0 and 1. But what about the numbers? Sorry, we are talking only about the numbers 0 and 1. But what about the numbers in between? That question matters. So that is when they started introducing the fractional part, which we call it as rational numbers. Okay. Then you have a counterpart of rational numbers, which cannot be expressed in that kind of a fraction. We call them as irrational numbers. This is the basic outline, but I want to put in depth. Okay. So first is, you know what is a number line, right? So you know what is a number line. Number line is basically used to represent various types of numbers. To be more specific, I'll be representing more various types of real numbers. Why am I using the word real and again and again? Do you think, is there any counterpart of real numbers? What are they? Do you think there is an opposite of real numbers also? You have imaginary numbers. Have you heard of this term? Yes. When will pi is an imaginary term? Pi is not imaginary, it is irrational. Square root of? Those are all irrational. You are getting confused between irrational and imaginary. Yes. Where did you learn that? That's right. You use the symbol I for it. Okay. So everybody knows how to take square root, right? Everybody knows it. Okay. If I put a question like this, x square is equal to 4, then what is the value of x? Which is equal to 2. Is that right? It is the very basic point. But according to me, x is equal to 2 is wrong. X is not equal to 2, rather it is equal to plus or minus 2. Why? Because what do you mean by square of a number? What is x square? What is the meaning of it? You take a number, multiply that number with itself. I repeat it, multiply that number with itself. So x square is equal to 4 means, what is the value of x that I can substitute? So you can either substitute 2 or minus 2, because 2 if you substitute, you will multiply 2 with itself, it will give you a 4. If you substitute minus 2, you will multiply minus 2 with itself, which will give you plus 4. So that is why whenever you are taking a square root, you are always supposed to write plus or minus. That is the actual way. That is the correct way of writing things. Okay. So plus or minus. See, similarly, I have x square is equal to half. X is equal to how much? Plus or minus 1 divided by root 2. So basically, how will you write? The intermediate step is x is equal to root of 1 by 2. But what are we supposed to add as a prefix to it? Plus or minus. Don't add that plus or minus inside the square root, add it outside the square root. Now I have an important question. If x square is equal to minus 2, tell me a number from the real number system which you can substitute in the place of x so that the square of that number will generate a minus 2. Listen to my question carefully, think and try to answer. X square is equal to minus 2. This is the equation. I am putting a question. You know the real number line. You think of whatever number you want. Okay. From the real number line, we take a real number and tell me that you can substitute the place of x, so that if you multiply that number, which you take from the real number line, if you multiply that number with itself, the output should come out as minus 2. So x square will be equal to minus 1 into 2. So you think x is equal to minus 2. Is that what you're saying? This is where we go wrong. That's good, at least you attempted. Okay. This is where we go wrong. This is where I wanted to introduce the concept of imaginary numbers. Think about it logically. When I told you x square is equal to 4, what did I tell x is equal to? Plus 2 or minus 2. Why did I say plus 2 or minus 2? If I take plus 2, I need to multiply plus 2 only with plus 2 to get a square. If I take minus 2, I need to multiply minus 2 only with minus 2 to get the output. Right? But is there a possibility where you multiply two positive numbers or you multiply two negative numbers together? Is there a possibility for you to get a negative number? You will get a negative number only in one scenario. When you multiply a positive and a negative number. But square clearly tells us that you should not take two different numbers and multiply. You should take the same number and multiply with itself. So x square is equal to minus 2 is not going to give you a real number. Means on the number line, you can never find any real number that will satisfy this equation. That is when you go to the concept of imaginary number. So the counterpart of imaginary number is, real number is imaginary number. About this, maybe slightly in detail, you will be having a grip in next year also. There is a chapter called quadratic equations. So the quadratic is basically the power of the variable is 2. Okay, quadratic polynomial. I don't think you have learned polynomial. Okay, so you have something called as quadratic equation. This is a quadratic equation. So when you solve this, you will not get real roots, you will get only imaginary roots. Now, are you able to understand? Right? So this is what we discussed. Let me just run through the concepts. One is natural numbers. So natural numbers start with 1 to infinity in today's world, right? So if you want to tell someone that you're taking the numbers from the real number only from natural number set, then there is something called as set. Have you heard of this word set? Set is basically collection of similar items. For example, on your table, I'm able to see MTG textbooks. Everything has the same color, right? Is there anyone having different color? Is having green? Are you guys having any different color? No, right? It's bought from the same vendor. You got the same copy of materials. So if I take all these materials, stack them one by one, and keep it on the table, I'll call it as a set of MTG Foundation Course Mathematics class. So basically, what does a set mean? Set is collection of similar items. So if you collect the numbers from 1 to infinity, 1, 2, 3, 4, 5, 6, so on till infinity, you call that set as a natural number set, and the natural number set is represented by the symbol capital N. Are you able to understand? Similarly, if you add a 0 to the natural number set, you call them as whole numbers. Generally, a set is written within a square bracket like this. Sorry, not square bracket, flower bracket like this. So you put a flower bracket, right? 0, 1, 2, 3. You keep these dots, right? Any person who's reading your paper will understand that you're trying to speak about whole numbers. So this is a representation of set, and you can call this as W is equal to. So the symbol used for whole number set is capital W, not small w. Okay. Similarly, for natural numbers, it is capital N. Okay. What will be the next set? You have integers. Okay. Integers, how will you write the set? So for any set, you need to put these kind of brackets. Okay. So the intermediate number will be 0. You will have positive natural numbers on this side. You will have negative natural numbers on this side. Right? Are you able to understand this? Right? If you write something like this, a person who's reading your paper will understand that you're dealing with integers. The symbol used for integer set is not I, it is capital Z. Okay. So, can you guys please make a note of these points alone? These points you will not find in the book that is given. The book will understand it and not pass through. So I hope everybody has a separate notes for each subject. I think that instruction was given in the first class itself, right? Have separate notes. Yeah. So first make a note of the word set. See, set is actually not from your 9th or 10th standard. You should be learning about it only in your 11th standard. But it's not a big thing that you need to wait till your 11th for you to understand. So what is basically set? What is set basically? Set is basically collection of similar items. Shall we proceed? Yes. So then we saw what are integers. So what are integers? So you have negative natural numbers, 0, or negative natural numbers plus whole numbers that I can call it as a negative natural numbers plus whole numbers. So negative natural number end with -1. Negative of natural numbers will end with -1. 0 to 0, 1, 2 will start with whole numbers. So the combination of these two is what is called as integers. Right? That is a different perspective of seeing. Now we are getting into the most important context, which is related to your syllabus. So we'll be solving problem based on this concept. What is it? Rational numbers. So what do you mean by rational numbers? What is rational number according to you? Don't look at the screen. You try to answer so that we'll have fraction of what? Fraction is basically a by b. Yes. Is it fractions of integers, fractions of natural numbers, fractions of whole numbers? What are they? Which one is more? Are you able to think what I asked? You told fraction. Fraction is right because everybody knows that it is written in the form of p by q, where this q is not equal to 0. There's a famous thing. But we need to go deep into the context. When you say p by q, right, you call it as a fractional form, and q is not equal to 0. What do those p and q represent? What are they? What you told is right. You need to be more confident. P and q are integers. Okay. If you take two integers and if you are able to write those two integers in the form p by q, where q is not equal to 0. Why they told q is not equal to 0 is 0 is a part of integer set. 0 is a part of integer set. So when you wrote the integer set here, 0 is a part, no. So what they are saying is when you are writing a rational number, you need to ensure that you take two integers from here, that you should not take the integer 0 in the denominator alone, but you are allowed to take it in the numerator. Because 1 by 0 will become infinity. You cannot define it. So whichever you cannot define is not a real number. Are you able to understand? That is the reason why this came into picture. So I want everybody to write this point. So what is a rational number? A rational number is a number which can be put in the form p and q, where, so please write it down. Are you able to see, guys? Or you want me to zoom in? Little better? Will this work? So rational number is a number which can be put in the form p by q, where p and q are both integers. For the most important thing, q should not be equal to 0. Okay, that is something very, very, very basic point. Now, this will lead us to another important question. So you're saying I can take integers and write them in the fractional form. That's what the definition tells. Okay, I'll be very careful that my denominator is not equal to 0. I'll be careful about it. Now I'm going to take two integers. Think about them. I'll take 2 by 4. Okay, or I'll come to that. I'll take 1 by 2 as of now. I'll take 1 by 2 and I'll take 1 by 3. Can I call this 1 by 2 and 1 by 3 according to the definition as rational numbers? What preliminary check will you do? It's a fraction accepted. Numerator is an integer. Denominator is also an integer which is non-zero value. Yes, it is rational. In both the cases, yes, it is a rational. But my question is, if you convert this rational number into a decimal form, so what do I mean by decimal form? You always know this, right? Fractional part and decimal part are interchangeable. So you can do that. So when you convert a fractional part into a decimal part, what will happen in the first case? 1 by 2 will lead you to what result? So 1 by 2 will lead you to 0.5. and 1 by 3 will lead you to, so 0.3333 so on till, which can be written as 0.3 with a bar on the top of it. So if you write something like this, what will the person understand? So the number is repeating, or I can call it as more technically recurring. Have you heard this word recurring? No. So I have defined it in terms of fraction. Okay, accepted. But I need to be more careful this time. I need to see whether a rational number is terminating or not terminating. So what can rational numbers be? So we concluded that half is also a rational number, 1 by 3 is also a rational number. But when I convert them to a decimal form, I'm able to see an important observation. What is it? 0.5, you're stopping with it. Means you do a long division method, you're stopping with 0.5. Is there any number after that? So zeros, you will not take it into consideration. 0.5, you're stopping. So can I call, when I say I'm stopping something, can I call it as terminating? So 1 by 2 is a terminating number when in the decimal form. Whereas 0.33 something is non-terminating. And when it is non-terminating, one more important point you need to observe is, though it is non-terminating, there is a number which is repeating itself. So from there is an alternate definition also that comes for a rational number. What is it? That is why they're saying the rational number is either a terminating or non-terminating, but it is always repeating. I repeat the statement, listen to this point. A rational number is either terminating. You understood what is the meaning of terminating or non-terminating, but it is always repeating. Repeating in the sense 0.3 is there, right? That number is repeating itself. That is why you still call it as a rational number. So this is the most important differentiating factor between rational and irrational. What will happen is, you would have learned irrational numbers as numbers which cannot be represented in the p-type. That is right. But to be more precise, you have to speak in the language of terminating and recurring. Irrational numbers are non-terminating, at the same time they are non-recurring also. That is why you say square root of 2, square root of 3, square root of 5, all these are irrational numbers. Are you guys able to understand what I'm trying to say? Means you can never write that square root of 2 in the form of decimal, in the form of fraction. You can never. You try whatever you want, you cannot write it. Are you able to understand? Please make a note of this. The rational number is either a terminating or non-terminating. Please understand. The rational number is either a terminating or non-terminating, but it has a repeating decimal value. So repeating is basic English, mathematical English is recurring. Yes. Yes, guys. Shall we proceed? Now the next question is, what about the sign of a rational number? Is it supposed to be always positive, always negative? It can be positive or negative. At the same time, it can be a zero also, which is a neutral, right? So these are the points. Then I told you about the imaginary numbers, right? If you take the combination of real number and imaginary number, we call that number as complex number. Okay. About complex number, you will be learning in depth in your 11th standard. You know the word, that's enough. Nobody will question you from that. Okay. Next is most important question I wanted to ask is, do you know what are factors and multiples? Because you use something called as prime factorization method, something like that. If you use LCM, you use HCF and all those things. What are factors and what are multiples? Yes, factors are used to, but factors when they are multiplied, they'll give you a bigger number. That's right. Correct. So if I take a number, for example, if I take 24, I'll make it even more simple. If I take 6 for that matter, okay. So 6 can be disintegrated, means broken into small parts. So when you break it into small part, what are all the numbers which are factors? So it is a multiple of 1, it is a multiple of 2, It is a multiple of 3 and it is a multiple of 6. So this 1, 2, 3, 6 are called as the factors of 6. Why I am using this word factors is in your polynomials, you will be learning saying that x plus 3 is a factor of some polynomial. At that point, you should have a clarity. Factors are basically the smallest parts which are used to construct a bigger number. So when you multiply factors, you will get a bigger number. The bigger number that you get by multiplying the factors is what is called as multiple. Okay. One more important point where you use these factors and multiples is where do you use factors? You have heard of this term called as HCF. What is it? Highest common. What is the third letter? Factor. Right. Third word is a factor. Similarly, LCM. Or you can call it the least common multiple. The third letter of the word is multiple. So that is where the factors and multiples play an important role. So to put it in simple terms, I would say something like this. When factors are multiplied, okay, this part alone you can write it. So it is like a chemical reaction. Factors are multiplied, you will get a multiple. If a multiple is broken, you get factors. Have this in your mind. Please make a note of this point. Right? Shall I proceed? Yeah? Copy. Yeah. Okay. Then you can classify the numbers as even numbers, odd numbers, you can call them as prime numbers, composite numbers, something like this. Okay. So what are even numbers basically? Multiples of 2 are what are called as even numbers. Even numbers are basically represented with the symbol 2n, where n stands for integer. You can make a note of that one. Even numbers are basically what they are integers. Even numbers are integers, which are multiples of 2. Okay. How are they represented? 2n or 2p, whatever you call it. The 2 is common. After that, whatever variable you want, you can use. Then what are odd numbers? All integers which are not even numbers are odd numbers. Right? That is the simplest way of defining. But how do you obtain that odd number from an even number? If I have 2, what is the odd number? What are the odd numbers associated with 2? One I can say 1, and the second is 3. So on the number line, I have 2 here. Okay. On the left of 2, I have 1. On the right of 2, I have 3. So both are integers. So 1 and 3, how can I obtain from 2? 2 minus 1 is this number. 2 plus 1 is this number. Similarly, I have 4. What are the numbers? 3 and 5. So how did I get that 4 from 2? 2 into 2. So 2n. So 2 into 2 minus 1. 2 into 2 plus 1. So similarly 6. 2 into 3 minus 1. 2 into 3 plus 1. So what will be the general form of an odd number? 2n plus 1 or 2n minus 1. Correct? Right? Next, what are prime numbers and composite numbers? What are prime numbers? Yes. So prime numbers are those numbers which have only 2 factors. What are those 2 factors? 1 and itself. So any number which has the factors as 1 and itself can be called as a prime number. Any number other than a prime number is called as a composite number. You have to understand. So this prime number is again important. I'll tell you. This year you will be doing it. I'll tell you. See, for example, Okay, there is no example here. Prime numbers, you know what are the numbers? 1 is not a prime number. Okay, by default, 1 is not a prime number. So prime numbers start with 2. 2, 3, 5, 7, 11, 13, 17, all these 17, 19, all these numbers are going to be prime numbers. 21 is a prime number. It's an odd number, that's it. Okay, for example, if I say 17, I can call it as prime number and odd number. So if I combine it, I can call it as an odd prime. Basically, if you see prime numbers, mostly they'll be only odd numbers. Because even numbers, they are divisible by 2. Right? Except 2, sorry. Yeah, except 2. So are prime numbers, okay? So numbers which are not prime are called composite numbers. Now I want to introduce one more term, which is called as co-prime. We call the numbers as co-prime. Co-prime is a hyphenated word. So what I'm trying to say is, you write P by Q form, right? That is a rational number. What are P and Q? Integers. So P and Q, when you write it in the rational form, you should always stop the number with in such a scenario where they don't have any common factor among them. Okay, so what should happen is, if P comma Q have no common factor between them, then such numbers are called as co-primes. Okay, where do you use this in the first place? I remember there is one exercise where they'll give you a decimal form and they'll ask you to convert it to P by Q form. Did you do that in your textbook? See, for example, they'll ask you to write 0.15 in the decimal form. Sorry, in the fractional form. Have you ever done it? What will you do? So you'll write this as 0.15 divided by 1. Okay. You will see the number of values after the decimal number. You will add those many zeros in the denominator. Right? And you will compensate it with the same number. How did I know that I should add 2 zeros? Because after decimal, I have 2 numbers. So I can write this as 15 divided by 100. So what you're basically doing is 0.15. Is it a rational number or not non-rational? Sorry, irrational number. It's a rational number because it is terminating. It is terminating, so it's a rational number. So rational number can be written in the form of P by Q. So when you try to write it in the form of P by Q, you are multiplying with 100 and dividing with 100. So I write it as 15 by 100. Can I call this 15 by 100 as the simplest form? No, because I have common factors that are existing between 15 and 100. So when you try to represent a rational number in your final answer, you should write it in a form that P and Q are co-primes. Co-primes means reduce it to the simplest form that is available. So it will become 3 divided by 20. Now you don't have any common factor between 3 and 20. So this is the rational number they're expecting. So 3 by 20 is exactly equal to 0.15. Now you got a grip of what are co-primes? Are you able to understand? Yes. Have this in your mind. Okay. So this I'll explain it again when we are solving problems. So the next one is you have something called as absolute value, or you call it as modulus of a real number. Okay. Any idea? Have you heard this word modulus? No? That's fine. Whether a number is positive or negative, if you put between these two parallel lines. So absolute value minus 2. What is the absolute value of minus 2? It is 2. So it will always generate the absolute value. It has a very, very, very significant application in your practicals and science, especially science practicals basically. Okay. So as of now, if you know this concept, that is enough. So whenever I say modulus, if I give you a number, you just need to write the positive of it. So modulus of 2 is 2 only, but modulus of minus 2 is also. Why is it so? And all those things in depth you learn in your 11th standard clearly. Is it clear? So I've told what is a rational number. Now, there is a question. There is a textbook question. Is 0 a rational number? Yes. No. 0 is not a. Yes, it is a rational number because you can still write it as 0 by 1. Because so they ask, is it rational number? Yes, it is. Right. Can you write it in the form P by Q? Yes, we can do it. You can write it as 0 by 1. What does a rational number definition tell us?
Denominator should not be 0. Numerator can be 0. So 0 by 1, where p and q both are integers and q is not equal to 0. That's the answer. Okay. So to conclude the whole story, this is what your real numbers are. I think you would have seen this circle already. So real numbers, what you have is you have rational numbers. Below rational numbers, you have integers. Below integers, you have whole numbers. And below whole numbers, you have natural numbers. The other completely different set is irrational numbers. So the combination of everything taken together is what we call it as a real number. Right? You got some grip, right? Now we can go to the next step, that is irrational numbers. So what are irrational numbers? I told you already. So this one, make a note. All real numbers are irrational. So irrational also, you're talking only for real numbers, not for imaginary. All real numbers are irrational if and only if their decimal representation is what? Is non-terminating and non-repeating or non-recurring. So the decimal representation should be non-repeating and non-recurring. Please make a note and underline it clearly. There is a chance you'll forget it. Please make a note. Right. You're not able to see? Is it fine? Is it better now? Okay. I hope it is clear. Don't write down every point, I'll explain it. Okay. So I want you to write only the definition. Remaining points I'll explain, and this notes will also be shared in the app. You can have a look at it there. Okay. So rational number and irrational number taken together form the set of real numbers. Set is collection. So collection of real numbers will contain rational and irrational numbers. Okay. Suppose if I take A and B to be two real numbers. So between the real numbers, what are the kinds of inequalities or equalities that we can frame? A can be greater than B, or A can be equal to B, or A can be less than B. So these two are called as inequalities, and this is called as equality. So these are all the possible things. Next is, when you take an irrational number, if you take the negative of it, is that negative number going to be irrational or rational? Negative of an irrational number is irrational. So that is another important point. Next is, if you take the sum of rational and irrational number, what is it going to be? Sum of a rational and irrational number will be, so 2 is a rational number, root 3 is an irrational number. If you take the sum of these two, this whole thing I can still call it as irrational. Okay. So if you take the product of a non-zero rational number and irrational number, for example, 2, if I multiply it with an irrational number root 3, this 2 root 3, is it still going to be irrational or rational? It is an irrational number. Okay. Now the next question is, the sum of two irrational numbers is not always an irrational number. Accepted? Can you give me an example for that? So if I do root 3 plus root 3, I will get 2 root 3. Root 3 is irrational. The other root 3 is also irrational. 2 root 3 is also irrational. Then according to your example, it becomes everything is irrational. Root 2 plus, again irrational. 2 root 2, no? There is some hint on the paper itself. You can see it. You can take the idea from point number 5. Point number 5, what did I say? Sum of rational plus irrational is irrational. So what is the irrational number that I formed by adding a rational and irrational? I got 2 plus root 3. Similarly, can I say the difference of rational and irrational is also irrational? 2 minus root 3 is also an irrational number. Okay. So 2 plus root 3 is an irrational number. plus 2 minus root 3 is an irrational number. But what happens here? Root 3 and root 3 will get cancelled. You get the output as 4. So what happens here is the sum of two irrational numbers need not be irrational every time, but sum of a rational and irrational is always irrational. Are you guys able to understand this point? This is a very, very, very important point. Please make a note of it. You know how to deal with exponents? You know how to rationalize with square roots are there. You have done it, right? So these are all the basics. So what did I write? 2 plus root 3 and 2 minus root 3. What are they called? It's called conjugate of each other. Yeah. Should I go to the next point? So I don't want you to write everything. Only the 8th point you can write. So sum of two irrational numbers is not always an irrational number. Please underline that, not always. Why is it so? 2 plus root 3 and 2 minus root 3 are the best examples. Or if you add two conjugates of irrational numbers, then you will get the answer as a rational number. Similarly, the product of two irrational numbers is not always an irrational number. For example, I take root 2 and I multiply it with root 3. What is it going to be? Root 6. Root 6 is also again going to be irrational number. Whereas, if I take an irrational number and multiply it with itself, I'm going to get 2. So in this case, it is irrational. In this case, it is rational. That is why the statement is very careful. Okay, they didn't say it is always a rational number. They didn't say that. They told it need not be always an irrational number. There is a lot of difference in it. I hope you are able to understand, right? So this one is another property with respect to irrational numbers. So these things will help you for your Olympiads and other things because you'll have a better thought process. Are you able to think? Right? So the last point, it is again the same point that is repeated. The product of two irrational numbers is not always an irrational. It's repeated again. Okay. So if you look at the examples of irrational numbers, right? So forget about 2.7. So forget about them. Look at this. 1.2343434 something it is going. Actually, there is a mistake here. These are all examples of rational numbers. There is a mistake. These are all rational numbers. See, for example, I take root 2. Okay. So what is root 2? 1.414. It keeps on going. It is never terminating. At the same time, if you see the way the pattern is going to get repeated, it is not going to have any recurring pattern. That is why you call it as an irrational number. See, this year, what you would have done is they would have asked you to plot that root 2 on a graph sheet. That's a very simple thing. But you need to have more clarity on why is root 2 in the first place an irrational number. Now, you are able to understand? Yes. Okay. Imaginary numbers, as I told you, you'll learn about this in your 11th standard. What you told is right. So you'll be using an I. You're able to see here. So when you see 3i, right, the meaning of it is 3 into root of minus 1. That is the meaning. Because square root of minus 1 does not exist. Square root of a negative number does not exist. But this has a lot of application. Complex numbers is very, very important in science. You will get it by the end of 11th standard, understanding why is it so. Okay. So again, the same graph that is repeated. Now we are going to get into the mathematical, I'll call it as the problems. Okay. Suppose you see the heading that we are going to deal is decimal representation. So when I say decimal representation, they will give you a rational number and they'll ask you to write it in the form of a decimal value. Right. So here it is P by Q to decimal form. So if you have P by Q and you want to convert it to decimal form, what do you do in the intermediate process? You do long division. That's it. Nothing outside this. You just do long division method and you write it. You stop whenever the remainder becomes 0. If the remainder does not become 0, it keeps repeating. These are the only two possibilities for rational numbers because I told you it is for P by Q. So here, when you take it, express 7 by 8 in the decimal form by long division method. How can you do that? I'll take 7, I'll divide it with 8. So how much will you get? 0. So I'm get 0. So 7, 0. So 70 means again I'm going to get 8. You will get 64 here, 60 a 0 being pulled down. So 60 means how much? 7 times I'm going to have 56 and I'll be left out with 4085. So 0.875 is a terminating number. So it is still a rational number. Okay. Similarly, if I take 35 by 16. So 35 by 16, when I'm going to do that, right, I'll get 2.1875. See, I'm assuming that you're good with this, so I'm not going in depth into this. Okay. So 2.1875. So this is also a terminating number, which is a rational number. Okay. Now the next question is, see, for example, if it is 2 by 3, for example, then how you write this as? You'll put a 0.6 bar. So you understood how you are going to get. So when you do the long division method, you can see the quotient 0.6 keeps repeating itself and it is a never ending process. You will get the same number for which we'll be again adding a 6 and the process keeps repeating. Okay, this is an easy point. Now the next thing is how you do the reverse process. How you do the reverse process. That is conversion of decimal forms into rational numbers of the form P by Q. That is what your first exercise in your NCERT is. Right. So this time what they will give you, decimal form is given and you have to convert it to P by Q form. So for that, what are we supposed to do? There are certain, depending on what kind of a decimal number is given to you, you follow two different algorithms. Algorithm means what? The steps to be followed, right? So what are the two types of decimal values that we know from the definition of rational numbers? One can be terminating or one can be non-terminating and recurring. So if terminating is given, there is one way of solving it. If non-terminating and recurring is given, there is another way of solving it. Shall we see them? Yeah, you already know this. Okay, I'm just going to give you a different perspective. That's it. So think about it and solve. For example, we took an example of we solved a problem 7 by 8, right? So when I solved 7 by 8, we got 0.875. So rational form was converted to decimal form. Now, if I give you the question as 0.875 and ask you to write it in the form of P by Q, what will be the answer you will get or you should get? You should get 7 by 8. So let's try to convert it and see. So how to do that? The first step is obtain the rational number. So this is applicable. Case 1 is applicable when the decimal number is of terminating nature. 875 is terminating. So for 87, if I don't have a bar on top of the numbers, I'll follow this procedure. So 0.875, I'll write by, so determine the number of digits in the decimal part. How many digits are there? 3. So put 1 in the denominator and put 3 zeros and compensate it with 1000. So 0.875 multiplied with 1000 is going to give you 875 divided by 1000. Okay. Can I call this also as a rational number? Yes, I can call it. But I told you whenever you are representing a P by Q form, what are you supposed to do? You need to ensure that the numbers in the numerator and denominators are co-primes of each other. So for them to become co-primes, I have to simplify them. How do I do that? So divide with 5, keep doing it. Do and tell me if you're getting 7 by 8. So 175 is what you get to start with 5. Then again, except again you divide it by 35 by 40. Except again divided by 7 by 5. Okay. Now 7 and 8 are co-prime of each other. One is odd and one is even of this. Right? So using the same logic, since we know the concept now it is time for us to develop time management. I want you to solve all these problems in 3 minutes. Good. Want to see the question? The first question is 0.15. Second question is 0.67, not 87. 0.675, how do you write that? 675 divided by 1000. Correct. Last number. Minus 25.687. 6875. That might take some time, but do this. How much? 400? Correct. 16. Minus 411 by 16. How many of you got that answer? These are all simple. Shall we move on to the next one? Now, the case number 2 is when you have a decimal representation which is non-terminating and repeating itself. If, for example, I have 0.6 bar, I have 0.16 bar, I have 0.123 bar. So how will you solve them? Can you tell me what are the steps to be followed? So for these kind, when you see that bar, right, the first thing is you should take that number as x. So First step is, for example, if I want to write 0.6 bar in the form of P by Q, I'll take that to be X. So 0.6666, something like this. Okay. Then I need to multiply on both the sides with the multiple of 10. With the multiple of 10, it can be 10, 100, 1000, anything. But in this problem, what am I supposed to multiply with? Y. There is only one number with a bar on top of it. So I'll multiply with 10 on both the sides. I'll get 6 point. Correct? So this is X and this is 10X. So now we need to subtract X from 10X. So when you subtract it, you get 9X is equal to 6. So how did I get that 9X is equal to? Is there anyone who's not able to understand? Want me to explain in detail? Everyone is clear? Okay. So 10X minus X means it is 9X is equal to 6. Then what will be the value of X is equal? How did I get that 6? Because 6.666 minus 0.666. Right? So X is equal to 6 divided by 9, which is going to be 2 divided by 3. Okay. So this is how you solve these problems. Right? So can you solve these 3 problems and show it to me? So 0.6 bar I completed. Or you can do from the second end. You do only the second end. 2 plus 0.35 bar. Thirty-five by third one. How did it? That's what I was about to tell you. That's shortcut. But don't use shortcut. Clearly. See, if you want water, please don't ask permission. You can complete it up. So, what are the steps? We'll go in the pre-transfer, and I'll explain you the way to directly write the answer. So, this directly writing the answer you can use in your CBSE exam to verify. Don't show that, okay? So, X is okay. Sorry. So, what is the second question? X is equal to 0.35 with a bar on top of it. So, how much should I multiply on both the sides? 2 numbers have got repeated. So, 100x is equal to 35.35 bar. Okay. Or I can write there 0.353535 keeps on going like this. This will be 35.353535. So 100x minus x is going to be 99x is equal to 35. Okay. This will be, which implies x is equal to 35 divided by 99. Similarly, 0.585 bar is, if I call this as x, 0.585, 585, 585, so on. If I call this as x, okay, then what should I multiply on both the sides? 1000. So, sorry, 585 keeps on going like this. You call it as 1000x. So what will you get? 999x is equal to 585. So x is equal to 585 divided by 999. Okay. One is, are you able to simplify this with 3? Okay. Yes, you can do it because 175 divided by 333 is what you will get. No, I have to divide it with 3, right? So 175, 17, 19. Yeah. Sorry. 195 divided by 333, again divisible by 3. So you will get 65 divided by 111. 65 divided by 111. Correct? But is there a way that you can arrive at this step even without doing all those steps? Can you directly write 585 divided by 999? What is the way of thinking about? That bar number. That's it. That's right. So what is the logic is, if it is 0.35 bar, right? You can directly write the answer as, so to remove the 35 bar, to bring the 35 to the left hand side, what will you multiply with? You will multiply with 100. So when you multiply with 100, it becomes, at last you are going to get that 35 only. Divided by that 100, from that 100 you are removing one x. So 100, if you remove one x, how much will you get? 99. So the number of digits that you have pushed to the left hand side divided by those many number of 9s in the denominator. See, for example, 0.585 with a bar on top of it. What will the answer be? 585 divided by 3 9s. So for example, I have 0.14234 bar. 14234 divided by 12345 9s. That is the logic. After that, simplifying and writing it in form of co-primes, you have to think about it. The simplest form you have to think. 1, 2, 3, 4, 5, no? 5 9s only, no? Okay. Not 5 zeros, but 6 digits. So 6 digits, then if you remove one, you will get a 5-digit number. That 5-digit number is 5 9s. You're able to understand? The logic still works. Thanks. You're able to understand? This is how it works. But as I told you, don't use this in your. Don't use it. Okay? It's only for you to know the answer. Right. After this, what are the topics given in your textbook? So how will you find the rational numbers? So suppose they have given 2 rational numbers, okay? Suppose they have given you 2 rational numbers like this, 1 by 2 and 1 by 3. And they ask you to find out 3 more rational numbers between them. What will you do? So if you take 1 by 2 and 1 by 3, which number is smaller? 1 by 3 is smaller. So when you take the number line, okay, this is what they expect you to do. This is where you are going to have 1 by 3. This is where you are going to have half. Then they are asking you to calculate 3 more rational numbers between these two. Means on the number line, you are supposed to find out 3 more numbers. They should exactly lie between these two. Where will they lie? So one of the numbers, you can easily say that it is going to be the midpoint of these two. So midpoint means what? It will exactly be half the way. Okay. That is why what you do is, the first step is you add 1 by 3 and 1 by 2 and exactly take the half of it. So 1 by 3 plus 1 by 2 divided by 2 is going to be how much? 5 by 6 divided by 2, it is going to be 5 by 12. So 5 by 12 is how much? 0. 0.4, somewhere 0.41, right? Check it. 5 by 8 is how much? Sorry, 5 by 12. Five, 12, 0 point. This is going to be how much? 50. So 48, you will get 24, 1, you will get 12, 8 will come here, again a 0, so 80. So 0.41 something you are going to, but this will, okay. So there it is a non-terminating but repeating itself. Correct? Huh? So you will have that number somewhere over here because 1 by 3 is how much? 1 by 3 is 0.3 bar and this is 0.5. So this number should be somewhere between these two. So that is what I'm trying to say. So so this is where somewhere 5 by 12 will lie. So the other two numbers, where can you find them? So you can find it between 1 by 3 and 5 by 12 and 5 by 12 and 1 by 2. So in between means what are we supposed to do? Take these two numbers, add them and divide it by 2. So when you divide by 2, you're exactly taking the midpoint. Can you do this? So how much will the answer be? Do take LCM and show it to me. 1 by 3 plus 5 by 12 divided by 2. How much? 9 by 24. I'm not checking it. Is 3 by 8. Huh? Okay. So 3, you found it for 1 by 3 and 5 by 12. So 3 by 8 will lie exactly at the midpoint of it. Now what is the other number you can find? Between 5 by 12 and half. Or else, what else can you do? You can find between 5 by 12 or 1 by 2. Or you can find between 1 by 3 and 3 by 8. Or you can find between 3 by 8 and 5 by 12. Or you can find between 3 by 8 and 1 by 2 also. It's your wish. So like this, how many other numbers they are asking? What is the logic? Whatever is the end numbers, end rational numbers they have given, add those two numbers and divide it by 2. Whatever result you get, take that result and add it to any one of the values and again divide it by 2 and keep continuing this process till you get how many other number of terms they are asking. For example, there is a problem in your textbook. They would have asked, find 7 rational numbers between the given two numbers. Now you can think about it. Why is it happening? Because they are in between. Are you able to understand? Yes. The next thing that they would ask you is, they'll give you a rational number and they'll ask you to plot it on the real number. How will you do it? By using a magnifying method. See, for example, let's go with the question. So you know what is this magnifying method, right? Right? So why are we doing it? Let's try to visualize it. See, for example, I want that's right. I'll come to that. So suppose you have 3.5. Okay. So first what you will do is, you know that 3.5 is a number that is going to lie between 3 and 4. It is easy for us. Okay. It is your wish again. So it is going to be between 3 and 4. 3.5 is going to be somewhere over here. If I want 3.57, then what should I do? So magnifying method means what is happening? 3.57 is going to be on the right of 3.5 and it will be on the left of 3.6. Correct? So 3.5 is there and 3.6 is there. But here I am having it as a cramped one. So what I will do is I'll magnify it. When I magnify it, I can still take some more points here. How many points can I take? I can take 10 points because 3.5 means I have 3.51, 3.52, 3.53. It keeps on going like this. Right? So where should I exactly plot it? So at the 7th line, I need to put a dot and a circle around it. So that will exactly give me 3.57. If I want 3.578, again magnify. So where should I put it? Between 3.57 and 3.58. So again between them, I'll draw 10 lines and I'll find the value. If I everyone able to understand why we are using this magnifying method? That is okay. The last 6 is a 9. And the last one more point that I will explain now. After that, you can solve the expression problems. How to plot an irrational number on a number. How to plot root 2 on a number line. How will you plot root 2 on a number line? I want logic. Okay. You are saying add on or square of those numbers will get added on. You know what is Pythagoras theorem, right? So square root of 2, how can I write it as? In terms of any natural numbers or integers, I can write it as, mostly I'll try to write it in terms of natural numbers only. I will write it as root of 1 square plus 1 square. Okay, root of 1 square plus 1 square means on the number line, right? On the number line, I'll have 0. Okay, 0 as the reference point. From 0, at a distance of 1 centimeter, I will take a point A. At point A, I will take a perpendicular to it of how much length? Another 1 centimeter. If I do this, what will I get? I will get a right angle here. For a right angle, if I join the extreme points, then I get the hypotenuse. So what is the hypotenuse? How is hypotenuse related to the adjacent and the opposite sides? So hypotenuse square is equal to, can I say something like this? OB square is equal to OA square plus AB square. So this is going to be 1 square plus 1 square. This is OB square. So OB is going to be root 2. So can I say this is going to be root 2? Now what will you do? You'll take a compass with O as the center and B as the end point. From there you'll cut an arc. When you cut that arc, what will happen to that arc? That arc will cut the number line somewhere over here. So this point will be exactly at the distance of root 2 from that 0. Is that right? Suppose I want to get root 3. But you need to be choosy about the numbers, right? Yes. So root 3, if I want, I will write it as root of 2 plus 1. But how did I get the 2? It is root 2 square plus 1 square. So first you need to find out that root 2. Okay, again this has to be subclassified. To find that root 2, what are you supposed to do? You'll take it as 1 square plus 1 square. You will follow this procedure. And from here, what will you do? You will take an other line perpendicular to this. We'll call it as BC. And that BC should be of how much length? How did you get that 1 centimeter? Because I need 1 centimeter. So this is one of the sides. So this will become one of the sides. This will become one of the sides. And this will become another side which are perpendicular to each other. Then I will join these two. Then how much will this side be? Root 3. Now I'll take O as the center and C as OC as the radius. From here, I'll cut an arc. And when I cut an arc, it will touch the curve somewhere over here. From the origin, this distance is going to be root 3. Accepted? So if I want root 5. So how will you get that 5? Root of, basically you'll write it as 5 is 2 plus 3. But how did you get the 2? This side only, no? From origin, if I call this point as C, okay, not C, I'll call this as D, then OD is root. Yeah. No, if you take it, it will become minus root 3. No, you're plotting minus root 3. Generally, positive numbers are on the right of 0. So you want to cut a complete semicircular arc, is that what you're saying? But generally, when, see, had the question been about draw a line segment, you could have taken it on the left hand side, no doubt about it. But since they told, plot it on a number line. Number line has a specific pattern. On the right of 0 is plus, on the left of 0 is negative. So you should not take it on left hand side. Okay, that will become what? Minus 2. Okay, that's why you take it only on the right hand side. Now you proceed in this way. Okay, so actually I'm late there by 15 minutes. Okay, is this time right? What is the time in your watch? 11:10. No? Yeah, I'm late by 10 minutes. So I have to go there. Can you guys try these problems? If there are any doubts, you can let me know. Okay. So one more thing is, write down a number. So this is the number. 63. You already got this. 636921088. Okay. This is the student support number on which you can message your doubts. So now you are going to solve something, right? So ma'am, Priya ma'am is going to be here. Whatever doubts you have, you consolidate them. And if you send to me on this number, I will look into it and clear it in the discourse. Okay. And apart from that, you have any other academic related doubt. So for example, today we had math class, next week we are going to have. If you have any doubt in between, you do not wait till the next class, you can reach out to me. Okay. But try to message me. If you call, I will not be able to attend because the phone will not be with me always. So there is a particular time at which I will be looking at it. I'll consolidate everything, solve the problems and send it. And did you know about the app that you will have recorded sessions and everything? Okay, so this class I have recorded. So this session I'll be uploading it in the app. You can have it as a future reference. Apart from the live recordings, you will be having pre-recorded lectures. Is I'll be adding some animations and all those things and try to explain them. Those things will be there for your for things to be made easy. Okay. So all the best. Okay, keep doing it. If there is any doubt, you can reach. Monday is Monday. I don't think you have. Monday you have to bring your chemistry books. Tuesday you will have a chemistry class. It will matter in a subject question. Okay. Okay.